The city of Montoro is located in the province of Córdoba in southern Spain. It is a small town with a population of roughly 10,000 people. Montoro has a rich history and is located on a cliff over the Guadalquivir River, which has been a critical artery in southern Spain for traffic and irrigation. Traditionally, the river has been a natural barrier that could only be crossed by a 15th century bridge. The Puente Nuevo de Montoro, or the New Montoro Bridge, creates a new crossing using modern materials and forms while showing respect to the beauty of the historic land around it. Jose Romo, director of FECOR Consulting Engineers in Madrid, Spain, and lecturer at the Polytechnic University of Madrid, designed the bridge, which was completed in 2009. During his visit to Princeton University, we had the opportunity to discuss with him the pre-designed studies and considerations he made due to their environment and other factors.
I study different possibilities, small cable stay bridge, and straddles bridge, and arc bridge. And this was the three selected options. In fact, we study more. But this was clearly the same. Well, there was the three main possibilities to have the same deck through one abutment to the other. In the area, you have more arch bridges, and well, this is a kind of tradition in the area, so that's why we finally went with this solution.
The final solution of these considerations was very sleek and attention-grabbing. The bridge is composed of three main components: its arch, deck, and piers. These components carry the applied loads on the bridge to the ground. Initially, forces that are applied on the deck from traffic or pedestrians travel up the hangers to the arch. The arch then carries these forces down to its base, where there is a vertical and horizontal component due to its inclination. The vertical component is then taken by the piers, while the horizontal component is counteracted by the area of the deck below the arch, which acts as a tie and is in tension. Observing the arch more closely, certain key features propel its structural significance. Composed of steel, its cross-section is hollow and changes as you move along its body. At the point where the arch connects with the deck, the arch is in the shape of a narrow diamond, while at its peak, its cross-section is wide. Its narrow base reduces the amount of area it takes up on the bridge lanes, while its wide peak increases lateral stability in the arch.
The idea here is to have a slender arch also, and for that I use normally in an arch like this you have a compression, uniform compression from the springs to the springs, but you have more problems of stability, lateral stability in the center of the bridge, because the first mode of instability is a lateral mode. So for that is more interesting to have a widened cross section on top, and that's why I changed this cross section from the springs to the crown of the arch.
The second component, its 200-meter continuous deck, is marveled at for its slenderness. This is one of the most striking features of the bridge. At the point where the deck is widest, the deck is only 1.3 meters deep. It is a composite box girder with a cross-section composed of an almost triangular steel box section and a reinforced concrete slab on the top. The entire deck is slightly sloped due to different land heights at both ends of the bridge, and its wide stature allows it to resist lateral wind forces. Its largest span of 60 meters is held up by the arch. Lastly, there are the piers, which are arranged in 5 pairs along the bottom of the deck. All have triangular cross-sections and are tapered from top to bottom. Their wide footprint allows for the bridge to have even better resistance to wind forces acting perpendicular to the bridge. The beam at the top of each set of piers provides greater resistance against buckling and lateral loads that can come from wind or flooding. We had the opportunity to discuss the construction process for the bridge with Jose Roma.
The initial idea was to launch the whole deck from one abutment, but due to the condition of the area, because you have only water in a part in the main span, finally we decided to do by cranes all the lateral spans, and also we were able to do the central span. For that we built a couple of temporary towers close to the river, and then build the arches, the arch on top of the deck, and then put the arch on charge by tensile the hangers.
After completion, the Puente Nuevo de Montoro bridge was well received and stands as a complement to the town of Montoro, visually and functionally, and is a prime example of efficiency in Spanish bridge design.